In this video, we're going to talk about converting repeating decimals to fractions. In our first example, we have 0.3 repeating. We're going to have to set up an equation here. X equals 0.3 repeating. Previously, we learned about the property of equality. This just means whatever I do to one side and I do to the other side, I'm not changing my equation. So we're going to have to take this into account when I have to get rid of my repeating decimal sign. Since we have 0.3 repeating, one decimal place is actually repeating. So we're going to multiply both sides by 10 to the first power. To the first power because only one decimal place is repeating. So 10x will equal 3.3 repeating. Well, I need to set up some sort of a subtraction problem here in order to get rid of my repeating decimal sign. So now we have to take into account that x just equals my 0.3 repeating. So let's line up my x's with my decimal places. So we will see if we go from right to left, my repeating decimals will cancel out, So we will just be left with 3 on my right side, and 10x minus x is just my 9x. So now we just have an equation, 9x equals 3. In order to solve for x, we divide both sides by 9. We will get 3 over 9. Well, let's simplify this. 3 divided by 3 is 1. 9 divided by 3 is 3. So now we just convert this into a fraction. In our next example, we will have 0.27 repeating. Well, now two decimal places are repeating, but we're still going to have to create an equation here. So x equals 0.27 repeating. Well, since two decimal places are repeating, we're now multiplying both sides by 10 squared. 10 squared is just 100. So we will get 100x equals 27.27 repeating. Again, we'll need our subtraction problem here. So we're going to have to line up my x's with my x and my decimal places with my decimal place. Going from right to left, we will see that my 27 repeating will cancel out, and I'm left with 99x equals 27. So rewriting my equation, 99x equals 27. We divide by 99, and I'm left with x equals my 27 over 99, and when we simplify here, we will get 3 over 11. In this last example, we have 0.416 repeating. Notice that my repeating sign is just over my 6, so my 41 does not repeat. So let's set up an equation here. X equals 0.416 repeating. Since 6 is just repeating once, we're again going to multiply both sides by 10 to the first power. So when we do that, we will have 10x equals 4.1666 and so on. So I have 10x equals 4.166 repeating. I put that extra 6 in there for our subtraction problem here. So let's line up my x equals, we know x equals my 0.416 repeating. Notice why I wrote that extra 6. So now my 6 repeating will cancel out. So just using our subtraction from right to left, 6 minus 1 will give us our 5. 1 minus 4, we're going to have to carry here. So then our 11 minus 4 will give us our 7. Then we have our 3. 10x minus x is just our 9. So 9x equals my 3.75. Again, I have to divide by x, so I have to solve for x, so I'm just going to divide by 9. So I'll get x equals 3.75 over 9. So x equals 3.75 over 9. Now this is not a normal fraction that we will see. So let's take this 3.75 and write that as a fraction. Well, we know that we have a whole number 3. And my 0.75 is just my 3/4. So now we have just written a mixed number. So in order to get this mixed number into an improper fraction, we will multiply 3 times 4. So my whole number times my denominator. 3 times 4 gives me the 12. And then I add my numerator, and I will get 15 over 4. So my 3.75 over 9 can just be written as 3.75 times my 1/9. But I already know that my 3.75 is just 15 over 4. So this equals my 15 over 4 times 1/9. Now when we're multiplying fractions, we just multiply straight across. So we will get my 15 over 36. So my 15 over 36 equals my x, but I'm not satisfied yet because I can still simplify this. So we will simplify this and we will get my 5 over 12 as my fraction.